Okay, Bobby. So last time we had seen that the battery is the limiting factor for a mobile phone. So what exactly is a battery? Technically, can you please explain to me what a battery is?
As we mentioned earlier, it's somewhere we can store energy and then use it. I can also, once it is empty or partially empty, I can charge it also.
Okay, but store energy. But what is the technically what is the unit of energy? I mean, what is the unit of, what does it store physically?
It stores electrical energy in a chemical form.
Okay, and how do you quantify this?
Um, there is a unit
Okay,
for the energy that is stored.
okay,
It's you might have seen milliampere hour. It is written.
okay. So what
So,
what is
for
the
example,
specification of this battery?
this one, it is mentioned 1510 milliampere hour.
Okay, iPhone 5S. Okay, iPhone 5S. You're saying it is
1510
1510
milliampere
milliamp
hour.
hour. Okay, we'll see this later.
Also, it's written 3.8 volt.
Okay, there's another number 3.8 volt. And is there any other number that you see on that battery?
It's also written 5.73 watt hour.
5.73 watt hour. Okay, so let's keep this in mind, and maybe we should also look at this, slightly smaller battery here. So what does this battery say? So I'll first write it down.
I think this is also same voltage.
Okay, so it's 3.8 volt.
Oh, sorry, 3.7 volt.
3.7 volt. Okay.
And 600 milliampere hour.
600 milliampere hour, is it? Where is it? This is 800 milliampere.
800.
Yeah,
Oh,
800.
sorry. Too small to read
Okay,
for me.
and this is 3 watt hours.
Yeah.
Okay. So one thing is evident straight away. Smaller the battery, you're going to have lower specifications in general, right? In
Yeah.
terms of
Yeah.
ampere hour, milliampere hour, or watt hour, and so on. So, so this is a 3.7 volt battery.
How do you know?
Well, it says
It's
so.
written.
It says so. Can you test it for me in some other way?
Maybe I can measure it using this multimeter.
Sure. So why don't we do that? So can you help me just
So
place
let's
the probes?
see. So I kept it in voltmeter,
Okay,
which will show the voltage.
okay.
I can manage.
Yes.
It says 3.62 volt.
Okay, so this is 3.62 volt. Okay, and of course this says 3.7 volt, but I think that's okay because with
Maybe
wear and tear, the battery might slightly lose a little bit of voltage.
Yeah,
And also it depends on what point of, how much of charge there is left in this battery,
exactly.
right? So yeah, we are convinced that, when they say 3.8 volt, the battery is going to be a 3.7 or 3.8 volt battery here, right? But
It also could be that the meter has some little bit error.
okay, yeah, that is also possible,
Yes.
right? So the measurement is about 3.6 volt. This is the, but what does this number mean, Bobby? 800 milliamp hours.
So it can give maybe 800 milliampere for an hour.
Okay, so you're saying that if I have a battery, which is of course represented with this symbol, and we are saying this is about 3.7 volt, and if I connect a device that is going to draw 800 milliamps, then this battery will last for 1 hour, is what you're saying. Okay, yes. So if this is the case, the battery will last 1 hour. And of course, if we had used the bigger battery, okay, this is the Nokia, right? And if we had used the iPhone and you drew a current here, and this is also, remember, approximately 3.8 volt. So you're saying now if I had drawn 1510 milliamps of current,
Again, 1 hour it can.
so this battery will last for
Approximately, yeah.
okay. Now, but what happens if from this battery, instead of 1510, if I drew only 800 milliamps?
Then, we can calculate.
Yeah, so you're saying approximately this is, if it is 1600, it's twice.
Yeah.
Right? Yeah. So you will say that if it is 800 milliamps,
almost 2
approximately 2 hours. Right? And of course, it is only 1510 milliamps that it lasts for 1 hour.
Yeah.
Right? So, okay, so I showed you this mobile, right? I showed you this mobile, the model of the mobile where there was a motherboard, and if you remember, right, there was this. So if you remember the picture of this phone, there was one battery, right, which was 3.8 volt, and this was connected to many ICs.
Yeah.
You had
those units were consuming power from the
exactly, right? So is it that each IC is going to consume 800 milliamps of current?
Not like that.
Not like that, right? So you will have maybe this one consuming 10 milliamps, the other one consuming 20 milliamps, and this one consuming 40 milliamps of current.
So on,
right?
Correct.
And so on. And of course, you have 1510 milliamp hour battery, right? So if you were doing an activity where each of these ICs were individually consuming 10, 20, and 40, then they're going to consume 70 milliamps of current total.
Correct.
So now it's very evident that if I were to perform these activities,
how
right,
long we can perform.
How long I can actually use this battery, right? So if I do that, 1510 is milliamp hour divided by 70 milliamps, right? So this is approximately what? 20 hours?
Yeah.
So if you were doing, for example, this could actually be browsing, right? And this activity could be, something like audio, right?
Yeah.
And this could be watching videos.
For example,
this is just a hypothetical example. I don't know if this is the true numbers, but if I did this, then your battery is going to last for 20 hours, right? So so this is exactly how the batteries are actually rated, first of all, right? So maybe I can switch over to a browser and show you that. So when we saw this page earlier, right? With respect to what the camera was and all that. Now let's just focus on the battery, right? So you see that this is 1560 milliamp hours. It can be slightly different, right? And the battery life, you see here, battery life endurance rating of 54 hours. So let's see what that actually means, and we will view all results here. Okay, so what I'm going to do is I'm going to scroll up. Okay, and let's look at what this page actually says. Okay, the endurance rating actually says that if you were to make 1 hour of calls, every day,
Mhm.
1 hour of web browsing, and 1 hour of video playback, right? That is the endurance rating, right? Then the iPhone 5s has an endurance rating of
54 hours.
54 hours, which means in one day, if you did web browsing, calls, and video playback for 1 hour, right, then you would have to recharge this phone completely to 100% once every 54 hours. So that is actually very
Approximately every 2 days I need to charge.
exactly approximately once, but that is exactly similar to what we were saying here. You have three different activities going on, right? Browsing, and maybe instead of this being audio, if I just make it calls, right, then each of these components will draw different currents, and the battery can serve this current for that many hours. So the endurance rating is 1 hour of video, call, and browsing.
Yeah.
Then 54 hours is what the battery will
That's
work.
for this model.
That is for this model of iPhone 5s, which has a rating of approximately 1500 milliamp hour, right, of a battery. Of course, if you tried it with this Nokia battery, it will be half of that. Correct. Right? You'll get only 27 hours. Correct. There, right? Of course, it's a different thing that this phone cannot support, all these multimedia activities like videos and browsing and all that. You can only do calls. Therefore, if you remember this Nokia phone, you charge it for fully to 100%. You can make calls for at least a week. You don't have to worry about charging this mobile, right? So there's nothing to beat this mobile in terms of endurance. Correct. If you were to use it only as a calling machine. So with this background of batteries, next we will get into how we actually charge a battery. By the way, you know that this is a lithium ion battery?
Yeah.
And did you know what a significant contribution this was to our society? In fact,
of course, yeah.
In fact,
there must be a Nobel Prize for this.
Exactly. 2019 Nobel Prize in chemistry, right? If you look at this person, Akira Yoshino, right? So if you look at it, he was given a Nobel Prize in chemistry for the development of lithium ion batteries. Cool. Right? So, and this is as late as 2019, by the way.
Yeah.
So it's been a significant development, and all our electronic gadgets today are powered by these lithium ion
By
batteries.
the way, who invented the first battery?
Oh, I have no idea. So you have a guess?
I can give a clue.
Yes.
Something to do with the unit of voltage.
I don't even know a scientist who is somebody called volts. Okay, let me ask Google uncle.
Yes.
Right?
Yes.
Who Okay, it was based on some findings by Galvani and Volta.
Yeah.
Okay, so that was the first battery. Of course, I think that was a much larger form factor.
Of course.
And it's the lithium-ion batteries that are actually so
now
small and make it, even viable for mobile devices today. So in the next lecture, we will move on to how you charge these batteries and what you have to do with